So now I'm going to teach you how to prove that some certain parts of overlapping triangles are congruent. So in this case, we have to prove that triangle AOB is isosceles. So AOB is over here. So for there to be an isosceles triangle, we have to have two congruent sides. So let's say we can prove that these two sides, AO and BO, are congruent. So in order for us to prove that, it's either we try to prove that these two triangles over here are congruent, for us to say that these two parts are congruent because of CPCTC, or what we can also do is prove that these two angles are congruent, and we can prove that these two sides are congruent by the converse of isosceles triangle theorem. So let's say we're going to go that path. Okay, so let's try to look at our given. It says here DA is congruent to CB and angle DAB is congruent to angle CBA. So there you have it. But as you can see, it's kind of hard to look at our figures when they're overlapping. So what we can do is we can draw the figures separately. So let me just draw the figures now. So as you can see, since we already have a pair of sides that are congruent and a pair of angles that are congruent, we need one more pair of parts that are congruent. And do you notice anything else that we can say that are congruent aside from the two givens? Okay, that's right. We can also say that AB is congruent to AB, and the reason would be reflexive property of equality. Okay, so now we can actually conclude that triangle DAB is congruent to triangle CBA. Okay, and that is by, so because of this part, so we can say that it's SAS congruence postulate. So now, since we have already proven that triangle DAB is congruent to triangle CBA, we can also say that angles DBA over here and CAB over here are congruent. And how is that? Okay, correct, because of CPCTC. Now, since these two angles are congruent, we can also say that the sides opposite to that, AO and BO, are congruent because of, can you come up with the reason? Okay, that's right. It's because of the converse of isosceles triangle theorem, which basically states that the sides opposite to the congruent angles are congruent. So now, can we say already that AOB is isosceles? Yes, so we can actually say that because of the definition of isosceles triangle. So we can conclude that already. We can put that as our last statement. And that's the end of the proof. So if you have any questions about this example, you can ask questions from your teacher, or you can actually rewatch the video and do it again if you want in your notebooks, and use this as your guide or as your answer key.